Hey guys, it's Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight we're talking about partial fractions and long division. So this is a Calculus 2 course, and I think you'll enjoy this one also. So let's get after it. Okay, we have a problem here. The integral of x squared divided by 1 minus x squared dx. Okay, well, what to do here? In previous videos we've talked about u sub, we've talked about trig sub, talked about a lot of things. If we tried u sub on this, let's not do that. Let's try long division. How about that? Back in the day, we did a lot of long division before the advent of calculators. Okay, let's see. Let's try x squared divided by, and I'm going to flip this around, minus x squared plus 1. Okay. Negative x squared goes into x squared negative 1 times. Negative 1 times negative x squared gives me a positive x squared. This is plus 0. So negative 1 times positive 1 gives me a negative 1. And as you know, you're subtracting all of this from above. X squared minus x squared gives me 0. 0 minus a negative 1 is plus a positive, so that ends up being 1. So I have a negative 1 with the remainder of 1 over this. So I have negative 1 plus 1 over, I'll flip it back around, 1 minus x squared. Okay, so I've reduced the power of this, and this becomes much more manageable. As a matter of fact, minus 1 plus 1 over 1 minus x times 1 plus x. So I can factor that into something even more manageable. Now, but only if I can utilize partial fractions. So let's think about this. We would now have the integral of minus, have multiple integrals here, have minus the integral of dx, so minus 1 dx, plus the integral of 1 over 1 minus x times 1 plus x dx. Now for a moment, I'm just going to work with this integral and we'll come back to this. As a matter of fact, let me just put it up here so I don't lose it. That's happened before. All right, so we'll continue on in a moment. So let's work with just this one. So we have the integral of 1 over 1 minus x times 1 plus x dx, and we're going to set that equal to a over 1 minus x plus b over 1 plus x. Now, as a matter of fact, for the moment, let me drop the integral sign, just work through this algebraically, knowing we're going to come back to that integral. So if I multiply both sides by 1 minus x times 1 plus x, so I'd have 1 minus x, 1 plus x. Okay, so if I do that, those cancel and I'm just left with 1. And if I multiply 1 minus x, 1 plus x to this, the 1 minus x cancel and I'm left with a times 1 plus x. And I do the same here, 1 minus x, 1 plus x. The 1 plus x cancels and I end up with b times 1 minus x. Okay. Now I'm trying to solve for a and b. So let's just say if x equals 1, this one cancels. So let's let x equal 1. So I have 1 equals a times 2, so 1 plus 1 is 2, and then 1 minus 1 is 0, so this term is gone. So if I divide both sides by 2, a equals 1/2. So I'm just going to write a equals 1/2 right here. And now b equals what? Okay, so let's erase this. Let's let let x equal -1. So that would cancel out this term. So let's let x equals -1. So 1 equals -1 plus 1 is 0, plus b times minus a negative is plus a positive, so that equals 2b. So once again, if I divide both sides by 2, b also equals 1/2. Now then, we had before this integral, and we were saying that integral equals now the integral of minus dx minus integral of dx plus 1/2, which was a, over 1 times 1 minus x, that's the integral of that, dx, plus b, 1/2. I'm about to run out of room there, I think. Let me get this, erase this, and move that down. So this equals minus the integral of dx plus a, the integral of a over 1 minus x dx, plus b over 1 plus x dx, as that integral. So that's what we had. And then the a was 1/2. I'll put it to the outside. b also was 1/2. I'll put it to the outside also. Now then, the integral of dx is x, so negative x plus 1/2. Oh, I don't know that we've studied this. I have 1 minus x in the denominator. If I move that up to the numerator, I have 1 minus x to the -1. So I'm trying to integrate that. Well, you know what the function of integration was. I'm taking n, what's up top, and I'm adding 1 to it, and then I'm dividing by the results. Uh-oh. That is why we have a natural log. A natural log is used for this particular situation. This would equate to the natural log of 1 minus x. That's what would happen here. So that said, I have the natural log of 1 minus x plus 1/2 the natural log of 1 plus x plus c, and they're all with the absolute value sign. So this is how you would use long division to reduce the power, to put it into something you can work with. And then this was just a general use of the partial fractions to be able to solve that, the resulting power reduction. Now, eventually we'll have some terms. Maybe you have 1 minus x, 1 plus x, and then maybe an x, or 1 plus x squared. Maybe you have an x squared term out here. And we'll show you how you handle that. But it basically, you've got an a over one of the functions, b over another one, cx plus d over the squared one. And you're just going through the same iteration to solve for a, b, c, and d. Okay, this was partial fractions and long division. Hopefully you enjoyed the video. Why do we do these things? Hey, so that together we can build a better tomorrow and do that through math. So that's all for now, and we'll talk to you next time.